In late 2009, a team of hundreds prepared to take a fleet of experimental aircraft through an exhaustive battery of tests. The goal? To establish, document, and certify the 787-8's operational envelope. This is a view into that incredible test program, a rare exploration of the total effort and coordination it takes to bring the aircraft through flight testing to certification.
Test Operations Center, Jim Palmer.
To safely and efficiently validate the 787's integrity, Boeing Test and Evaluation developed a new way to manage the test process, creating the Test Operations System to maintain 24-hour oversight of its fleet of test aircraft. Mike Fromm oversees flight test engineering for Boeing's commercial aircraft. His team would travel the world, testing the 787's operating limits.
With each successive flight test program and the requirements that have been levied on us by the regulatory agencies as well as the programs, we've had to develop robust and complete flight test programs that allow us to accomplish those requirements in a very safe and efficient manner.
With the plan in place, the 787 neared its first flight. This would be among the most closely scrutinized test programs in Boeing history.
Here at Boeing Test and Evaluation, there are three major areas that we concentrate on in trying to get the airplane ready for service. First area is certification through the FAA and trying to get the airplane certified and the follow-on certification agencies. The other big area that we do concentrate on very specifically is safety. Safety of our crews and safety of the airplane and getting it safe to operate in service. And the third area is where we take the huge volume of data that we collect while we're flight testing the airplane and reduce that data down into the flight manuals that the airlines and the pilots of those airlines will utilize to operate the airplane.
Engineering test pilots, working in tandem with flight test engineers, would record their findings and analyze test results, both in real time and over the course of the test program. Also on hand to document the testing process would be a crew of scientific photographers. This team would observe many of the tests from the air and ground. They play a critical role in safety and testing, beginning with the first flight. On December 15, 2009, with thousands of spectators and watchful chase aircraft counting the moments before takeoff, ZA-001, the first of the 787 test fleet, was ready for flight.
Brake release.
This was it, the starting point in the flight test regime. Validation of initial airworthiness, the first of thousands of test flights for the 787 fleet. Now the Boeing Test and Evaluation flight test teams would kick into high gear on the 787. Each test condition would expand the Dreamliner's operating envelope.
Good morning, Boeing 001.
Inside a telemetry room in Seattle, engineers sharpen their focus in anticipation of flutter testing. To a casual observer, it might appear benign, but this test challenges the 787's entire structure by inducing vibration into the airframe.
Nose up. In 3, 2, 1.
With flutter, what we're trying to do is to excite the structural modes of the airplane, either through column and going up and down or through rudder and back and forth. And so you're trying to shake the airplane and get the structural modes excited. And what you're looking for is a natural dampening of the airplane in order for those vibrations to naturally dampen out.
Flutter testing clears the way for high-speed tests, and the program moves on to stalls to further understand the Dreamliner's aerodynamic performance characteristics. The pilot maneuvers the airplane to alter the angle of attack until the airflow over the wing breaks down. These tests determine the speeds and configurations that will create a loss of airspeed and a subsequent stall.
The 787 has enhanced stall protection. So enhanced stall protection allows the pilot to be able to have the full lift capability of the airplane at their command. And that underlies the overall Boeing philosophy of having the pilot in full command of the capability of the airplane.
Far from the open skies over the Pacific Northwest, a very different battery of tests awaits the Dreamliner. Crews traveled to the California desert to test and document the 787's takeoff performance.
Early rotations, rapid rotations, over rotations. We do all these tests at Edwards because of this 15,000-foot paved runway with the miles of overrun onto the dry lake bed.
Early rotation is pitching up too early. Rapid rotation is pitching up too fast. And over rotation is pitching up too far, essentially yanking back on the column. And what we're trying to do is to gather all the information together such that the pilot knows, hey, if I get into a situation like this, I know the airplane has the capability of getting out.
Understanding how the airplane performs in peak operating conditions and under duress in the event of an unplanned incident is critical to certifying the airplane for commercial use.
With VMUs, what we're looking at is to find the minimum speed and runway length it takes to get the airplane in the air. As the airplane is rolling down the runway at precisely the minimum speed, the pilot pulls back on the column, rotates the airplane up, drags the tail down the runway, and the airplane lifts off into the air.
In addition to simulating pilot error, rigorous testing is done to understand the 787's performance in the unlikely event of an equipment malfunction, such as an engine failure. VMCG, or Velocity for Minimum Control on the Ground, puts the airplane and aircrew through that scenario.
With VMCG, the airplane is rolling down the runway. One engine deliberately fails. The pilot has 1 second to react, then engages the rudder to compensate for the engine out without deviating more than the required distance.
The 787's flight controls play a major role in safely coping with unplanned events. In addition to testing flight controls, the team will test the Dreamliner's material components. One of the most dramatic tests comes during a rejected or refused takeoff.
With RTO, we have the airplane at max takeoff weight, accelerating down the runway past the point of go, no go on the takeoff. And then we perform a refused takeoff. The pilot aborts the takeoff, cutting the throttle, slamming on the brakes without the use of thrust reversers. The brakes are heating up to the point of combustion, so this is a tremendous amount of energy that we're trying to stop.
A fuse plug system in the wheels allowed the tires to safely deflate during the event. And after waiting 5 minutes, in order to simulate a fire response time at a large airport, the red-hot brakes are doused with water. It has gone as planned. Another success. A major component of flight testing is certifying that the aircraft can operate in various environments around the globe.
We monitor weather conditions at various airports looking for sustained crosswinds. One of the most consistent locations is in Iceland.
Keflavik Airport in Iceland is subject to heavy crosswinds, and pilots verify that the airplane can safely cope with the difficult conditions. They are literally writing the book on such landings. Certifying that the 787 can operate in challenging environments for any aircraft brings the test team to La Paz, Bolivia. At an airport 13,000 feet high, the airplane proves its aerodynamic and engine performance in a series of test conditions.
High-altitude testing is required to demonstrate the airplane's performance capability as the engines face the challenge of thinner air.
Only flight test photography equipment and a bird greeting the eastern Montana morning break the quiet of the prairie. Boeing test and evaluation crews have come to this still corner of the country to measure the noise footprint of the 787.
Using an array of highly sensitive microphones, we can develop an incredibly detailed noise profile.
From ground-based noise testing to airborne cabin environment tests, and stalls to endurance flights lasting well over 19 hours. The 787 would be put through more airborne testing than any Boeing commercial aircraft before it.
Through the thousands of hours of testing in the many locations around the world, and the great sacrifice of people being away from their families for an extended period of time, it all culminates at the end when they know that that sacrifice that they put forward ended up in the certification of the airplane.
It would all lead the Dreamliner here, a customer airline, and the many thousands of passengers who will travel safely around the world on a commercial aircraft whose performance has been tested and validated to a degree never seen before. Designed to the specifications of commercial aviation's future, the Dreamliner builds on the history of Boeing's innovation, and with an unprecedented flight test effort behind it, building trust in the name Boeing.